In this video, we will learn about Modbus RTU communication. Using Modbus RTU, we have PLC. As you can see, we have PLC with COM1 port and COM2 port, and we have a scanner module, 8-channel scanner module. This has RS485 communication port inbuilt in it, and we have a laptop with a serial communication port. So what we will be doing today, we will communicate PLC with scanner module which has RS485 port. Scanner module is nothing but it can accept analog inputs, various sensor input, and will display. So this is our PLC, and the front port which you are seeing is a COM1 port, and this left side port, this is a COM2 port, and this we will use as RS485 port. RS485 communication we will be using here. So, and this is the power up terminal, and this PLC is a DC 24 volt power up, which is we have already connected DC power terminals. And today our focus will be in learning RS485 communication, how we will use PLC to communicate with the scanner module. This is the 8-channel scanner module, and basically it has 8 inputs, universal inputs. It can accept all types of inputs. See here, this is the connection diagram of this scanner module. 1 2 is a line neutral power up terminals. RS485 terminals are D plus and D minus, that is 25 and 26, and other one channel 5 we can see here. These are the analog signals. We can give RTD signals, thermocouple, voltage, and milliampere signal. We have 8 such type of analog inputs which this scanner module can accept. At the back side of this scanner module, we have all the terminals as per the diagram, and right now we have connected power terminals. Line and neutral terminals are already connected, and at the right side we have analog input terminal. We are using 4 to 20 milliampere signal, and we have also connected 100 ohm resistance parallel to this 4 to 20 milliampere signal. As per the indication here, these were the D plus and D minus terminal, RS485 terminals. See here, D plus and D minus are 25 and 26 terminal, RS485. We will connect our communication cable at this terminal, and we have used channel 1 only. We have only connected channel 1 at terminal 14 and 15. We are using milliampere signal, and also we have connected 100 ohm resistance across it as per its recommendation. So this is our scanner module, and we will be using it to communicate. The third thing we have is a laptop which has a COM port, so that we can program our PLC using this port. If you don't have in your laptop COM port, then you can use USB to serial port converter. So we have our COM port in our laptop, and we will be using this port to communicate and download the program, ladder logic program, to the PLC. Next we have this RS485 communication cable. This is the RJ connector, and as you can see we have used only 2 wires, and which are connected at the one side, at the first and second terminals of this RJ connector. This is the basically wiring diagram recommended as per the PLC port terminal. So only wire, we have used only 2 wires, and at the one and second terminals we have punched it at this RJ port, and the other side of this cable we have left open free wires. We have left open 2 wires These two wires will be connected to the D plus and D minus terminals of scanner for data communication. So we have left it this way. Next, this is our PLC programming cable, and both side we have serial, but one side we have male connector and other side we have female connector. At one side we will be using, basically we will be connecting it to the laptop COM port, and other side we will use it PLC COM port. So female side will be connected here at the laptop side, and we are connecting, as you can see here, we have connected this port, cable port, at the laptop side, and the other side, this one, we will connect it at the PLC COM1 port for programming purpose. So we are getting our systems ready so that we can start working. This is our RS485 communication cable, and this is the RJ port which we are fixing at this left side of this port, PLC port. This is basically a COM2 port of PLC which we will configure as RS485 port. And the other side of this RS485 communication cable, we will connect it at this scanner module D plus and D minus terminals, which are RS485 terminals. So these are the terminals 25 and 26, and we have connected here, as you can see here. So this is the basically data terminals D plus and D minus of this scanner module. And this one is basically analog input signal, and this is a resistance, 100 ohm resistance, which we have connected across 4 to 20 milliampere signal, which we have connected at these terminal. This is a channel 1 of scanner module, and this 1 and 2 are the power supply terminals to power up the scanner module. So we have completed the connection of this scanner module, and now we have switched on the power, and you can see here channel 1, channel 2, channel 3, 4. It is going sequentially, and it is showing open circuit, and at only channel 1 it is showing some figure value because we have connected analog signal at channel 1. So we have put it, this scanner module, to manual mode, and now it will not scroll automatically. See, we have fixed it to channel 1, and it is showing some value, that is 7645 milliampere. Basically it is showing value according to our signal, 4 to 20 milliampere signal, and we can vary our signal using this potentiometer, and you can see the figure also varies. The numerical figure data value is varying by varying our potentiometer. So we have controlled our 4 to 20 milliampere signal in this way. Now our scanner module is getting one value at this channel 1, and this value we will be communicating, we will be reading in our PLC using RS485 Modbus RTU communication. For this we have to understand some basics. Let us see here, this is a baud rate, this is and parity and stop bit. These are the three things we have to match at the PLC side and at the scanner side. So baud rate is 9600 bps, bits per second, or 19.2 kilobit per second. Parity can be odd, even, and NaN. So these have to be matched at both the sides. So see here one more concept, that is node concept. We have a master PLC, master port, RS485 port, and this will communicate with node 1, node 2, node 3. These are the various meters, and that can be called as a slave. So this is our slave module. You can see here scanner is basically slave module, and now we will check the communication setting of scanner module. So we have to go to level. This is level 2, level 3. We will explore the settings of communication settings of scanner, and this is a password. It is asking default is 0 password, and we will go through it. Now see, this is various parameters, and we have to explore only communication. I will check only communication parameters. This is scan type. These are the parameters. See, this is a serial number. This is basically a node number of this module, and we have set it as 1. Basically this is a slave module 1. Okay, now the next, this is a baud rate of a baud bit rate, and this is 9600 bits per second. It is configured. Okay, and this is parity and stop bit. PR and is parity, ST is stop bit. So parity is none and stop bit is 1. This is showing we have set it as parity none, stop bit 1. So we have known these are the three parameters which have to be matched with the PLC settings. Now we will come to our PLC and we will start ladder logic. We have to build a small logic program to read the mm, parameters of scanner module. So we have opened the LXsoft. This is a programming ladder logic programming of this LNT PLC LX series, and we are creating a new project, and we will name it as scanner com. So let this project name be a scanner com. We have LX7 PLC, and we will click OK. So we have created a fresh new project, and we will build a small ladder logic program here. We will create a first line, that is first rung, and now first of all we will take one bit, that is system bit F0.15. F0.15 is a system bit of PLC, and basically this is a run bit. So we will come in a comment section, we will write it as a run bit. Basically this bit will get on when the PLC is in run mode. So we are using this bit for our logic, and basically when the PLC is in run mode we have to configure particular bits. Let it, we will see here. Those bits that have to be put high, so we will use in this way. When the PLC will be in run mode, these bits will be particularly set at the on condition 1. So F13.12 and F12.9, these are also a system bit that has to be put in on condition if we want to use this RS485 communication in PLC COM2 port. Basically F12.9 is enable Modbus RTU communication bit. This is basically a enable Modbus communication bit. If this is set high, then it will enable the communication at COM2 port of PLC. So we have set the required bits that have to be put in on condition. Next, in our next line, we will set the baud rate of PLC COM2 port. As our scanner module has 9600 setting of baud rate, so we will set here PLC also as 9600. For that, F1.0 we are using, this is also a system bit, and this is a first scan bit. Basically this will get on during the first scan time of a PLC. When the PLC is switched to run mode, this is the on during the first scan time only. This instant F1.0 scan first scan bit will get on for that particular moment, and at that particular moment we will set speed of that COM2 port to 9600, and for that we will using let instruction to move data 96. We will move the settings to this COM2 register, speed register. So we have status register SR510. This is a state system register which holds the communication speed value of COM2 port. So we are giving it as value. This is D is a destination register, S is a source value. So 32768 we are putting it here, and it will basically set the COM2 port to 9600 bps, bits per second. So we have set the speed of COM2 port, that was our RS485 communication port. And next, in our next line we are using run bit and as an input condition. And now we will use a Modbus communication instruction, that is in advanced communication. It is not in the communication, it is in advanced communication. It is a Modcom. Modcom is a Modbus communication instructions, and we will use this to read the scanner module data. See, in this instruction we have port, and port is basically the PLC port which we will be using, and COM2 port is there, so we will put here 2, value 2, because 2 indicates for a COM2 port of PLC. And SID is basically a slave ID. Basically a slave ID means number, and we have used scanner module is 1, node 1, so we have put it 1. Slave address is basically the starting address, we have 0. And register we are using as word register W0, and we will read 8 registers as we have 8 signals. And status is basically a memory register where PLC stores the instructions status, Modcom status registers. So let it be M5. And FNC is basically a function code of Modbus communication, and we have used F04, that is input register, to read the input register, and timeout is basically a 300 millisecond. So we are using this Modcom instruction to read input registers, and the value will be stored at W0 registers. So we have filled up all the required details at the Modcom instruction. And now one more thing, we are using one NC of this M status register M5.3. This is basically a done bit of this instruction. So initially this is all, this is true, the condition is true, and it once the Modcom instruction reads completely the value, it is done. So the NC bit resets itself this instruction. In this way we have completed our this ladder logic to read the Modcom instruction, and we have compiled also with no errors. Now it's time to save and download this program to PLC. So we are saving it at the desktop, and we will save here, and next we will download it to PLC. We will go online option and then LXoft to PLC. We will click this option to download it to PLC, and the default CPU ID is 255, that is OK. So we will click OK, and it is asking, do you want to continue? Yes. Download completed. OK. Now we will check it one thing, that this is online but the PLC is in pause mode. We have to switch it to run mode, so we will click this option and we will select the run, and then OK. Now the PLC is in run mode and is online right now. So our logic is online with PLC run mode, and we can see here Modcom instruction. This is showing that it is in run mode. Now you can see here our registers are shall our word w0 is the word register where value will be stored. So let us check it, and for that we will go to monitoring, register monitoring. We will opt for monitoring option and we will click here, and here we have register monitoring, and these are the various registers. We have to go to w register. We'll click the w tab, and here you can see w0 is showing some value that is 6553, and other registers are showing 32767, that is the full value of particular data bit. So at channel 1, starting channel only, we have connected analog module 4 to 20 signal. See here, this is the scanner module. At channel 1 we have this is showing 6554, and the same thing we shall be getting here. In fact, we are getting here at PLC 6554. So we are reading this value through RS485 Modbus RTU communication, and now we will vary this value and see we have instantaneous change at the PLC side also. So it is very fast, instantaneous, and we are varying the value at the scanner, and instantaneously it is updated at the PLC side. So in this way we can communicate n numbers of meters, basically more, up to 31. So we can communicate other also. So, and hope you have learned how to communicate this and how to use Modbus RTU communication with PLC. In other PLCs also the concept will be same, but the things may be different a bit, but none of the concepts will be different. Hope you have learned it and enjoyed. Thank you for watching it.